Takes an array A and index I, and you rearrange the elements such that any elements that are less than the pivot comes first, followed by those that are equal to the pivot and those that are greater than the pivot. So what does this mean? So if you're giving an array 0, 1, 2, 0, 2, 1, 1, and the index is 1, so the index position is right here. This is the index position, 1. Then we define a pivot as A of the index, which is 1, basically. In this case is 1. Then our output has to rearrange in such a way that, so we are sorting it. That's actually a name for this sort. Where elements that are less than 1 comes first, elements that are equal to 1, the elements that are greater than 1. This is an output of it. Now, if we using the same array, if we choose a different index, 0, 1, 2, 3, 4. 0, 1, 2, 3, 4 is over here. And then the pivot for that is actually 2. So, as long as elements that are less than comes first, so as you can see, there's more than one way of doing this. The goal is not to sort them. The goal is just to be less than the pivot. And you have 3 possible answers. So I'm going to solve this 2 ways. The first way I'm going to solve it is not worrying about memory, assuming we have unlimited memory. So the space complexity is going to be big O of n. So is the time complexity, big O of n. But the space complexity is going to be big O of n. And then my second solution, I'm going to do it in place with constant space. So we're going to see the difference in here, okay? This is a very good problem to see how both works. So I already have the function here for you. Here's a test set that we're going to use, index of 1. And then we're going to create another one, index for 4. No, let's do the solution first. So one of the first thing I like to do is define my length, n. And then define my pivot. Let's do it separately. My pivot is going to be there we go. And then I'm going to define arrays that I'm going to need since I have unlimited memory. So the first one, let's call it less than array. Second one, let's call it equal to. And the last one, let's call it greater than. Then we're going to loop through. We're going to loop through the array. I is less than equal to n. I plus plus. So we're going to check first if it's less than. So we'll say if array of I is less than the pivot, all we have to do is just push it. Push array of I. And then we're going to check if it's equal to the pivot. Then we push it to equal to array. And we're going to check if it's greater than the pivot. And we push it into the greater than array. And then this is just as simple as just returning the spread of everything. So less than comes first, equal to, and greater than. And that's it. Now this should work. Let's test it out. And as you can see right here, this is what we're giving, and our solution does work. 0, 0, 1, 1, 1, 2, 2, 2. It's arranged for us. There's only one solution for this. So now we're going to try with an index of 4. So let's just copy this solution set. But the pivot is going to be, the index is going to be 4. So let's see. Index is 4. as you can see, this is the first example. We you know what? We can comment this one out so it's not confusing. Now let's do it again. There we go. The 2 is the index. It's rearranged. 0, 1, 0, 1, 1. 0, 1, 0, 1 is one of the solutions. 0, 1, 0, 1. The way it's sorted doesn't matter. So that solves it. That's the one way of doing things. But it's not the most efficient way. Because here, yes, let's look at this. Let's look at this code. The time complexity is big O of n, but the space complexity is also big O of n. So, but what we want is we want to do it in place. So what I'm gonna do is I'm just gonna remove this in place. Let's call it in place solution. Keep all of this. Pivot. Let's remove all of this. There we go. Let's comment this out as well. And then let's solve this. Now here is I actually created something for us to think about so we can see how my in-place solution would work. So let's start first with this. So given this array, we're using the same array. I'm going to create 2 pointers. One is a start pointer, one is an end pointer. And I'm going to have the start move to the right. I'm going to have the end move to the left. Because I'm doing it in place. So I need other help. Now in my loop, in my first loop, you know what? Let's not show the end one here, because I'm not really interested about the end one in the first loop. And in the second loop, I'm not interested about this one. All right. So in my first loop, with the start pointer, I'm going to ask myself, is 0 less than 2? 2 is the pivot. And the answer is yes. So then I'm going to swap 0 with wherever the start pointer is at. 0. In this case, it's both at 0. So swap 0 with 0. Doesn't do anything. Then I'm going to move. This to the next one. Just to the next one. And then my loop as well goes to the next one. Then the same thing. Is 1 less than 2? Yes. Then swap 1 with where start is 1. Nothing happens again. Because it's the same thing. Is it less than or equal? Same thing with 2. Is less than or equal. Same thing with 0. All this time, my start is moving along because I'm swapping them. They're all less than 2. So it's going to go through like this all the way until the end, because nothing happens. We're just swapping it with itself. So it ends here and it stays the same place because all of these elements are less than or equal than the pivot. That's fine. So now in our second loop, outside of the first loop, so that the time complexity is still big O of n, now we're going to start with the end pointer. Now the question is a little different. We're going to ask, is one greater or equal than 2? The answer is no. So this moves, but this stays because it's not greater. Is 1 greater than 2? No. The answer is no. This moves. Is 2 greater or equal than 2? The pivot. Yes, it is. So swap it with 1. So since this is in place, all we're doing is just we're doing this. We're going to swap it with wherever the end is at. So this becomes a 1. This becomes a 2. Here's our pivot, and this is not a pivot number. This is 1. Now this gets to move. This gets to move to the next one. And the loop moves. This moves as well to the next one. Same thing. is 0 greater than the pivot 2? No, it's not. So this stays where it is, and this moves. Is 2 greater or equal than the pivot? Yes, it is. So swap it with wherever the n1 is at. So this 2 becomes a 1, and this becomes a 2. And then this moves to here, and this obviously moves to the next one. Is 1 greater or equal to 2? No, it's not. 0? No, it's not. So we're done. And look what we have. We have a sorted array where numbers, elements less than the pivot comes first, and those that are equal to, then those are greater than. In this case, there's nothing greater than 2. So let's see how this looks when we're solving it. Alright, so the first thing I want to do is define those pointers. So we're going to use let as opposed to const because they change. We're going to call it start equals 0, end equals n minus 1. Right? Because n minus 1 is where it's going to start at. 0 is, it's the last element of the array. And then the next thing I'm going to do is I'm going to say for, I'm going to say let I equals 0. This is my first loop that I just explained. First loop. I'm going to say I is less than n, I plus plus. If array of I is less than or equal to the pivot, we're going to do our swap. And then we're going to increment the start. Increment it, increase the start. So start plus plus. Remember the start plus plus, this moves forward if the condition is true. And this moves backward if the condition is true. So that's what the increment is. So how do we do a swap? A swap is pretty easy. We're going to use create something called temp to hold a value for us, to hold one of the values for us, and then we're going to say array of I equals array of start, and then array of start equals temp. That's it. We've swapped it. And that's the first one. That's the first loop. We're going to do a second loop. We're going to say for let j equals n minus 1. J has to be greater or equal to 0, and j minus minus is our second loop. Now we're going to say if array of j is greater or equal to the pivot, again we're going to do swap, and we're going to decrease. So end minus minus. Same thing, swap, just going to change some of the variables from I to j and from start to end. And that's it. We don't need to, we can return the array. So we didn't create ABC we didn't create all the other 3 extra arrays. We did this in place, just swapping things around. This is a more efficient solution in my opinion. Let's test it out. Let's test the first one out with index of 1. Should give us the same solution. Let's clear this. What is it saying? Oh, the first solution is not defined. I have to give the name. There we go. Change the name because I changed the name of the function. There we go. Perfect. It works. Now let's try the second one. Set to the index of 4. Perfect. 0, 1, 1, 0. See, this one did 0, 1, 1, 0, 1. 0, 1, 1, 0, 1. See, you even give a different one from one of the answers because there's many ways of doing this as long as the values are less. That's it. Thank you.